Hi, we have made a distributed chat application for our distributed system final project. Let's go ahead and understand this distributed chat application in detail. To start with, let's understand what we are going to discuss today. First, we will see an introduction of what a distributed chat application is like. Then we'll go ahead with history and background of chatting systems. After that, we will emphasize on some of the features of distributed chat applications, followed by understanding its architecture in detail. After that, we will see the implementation part of this chat application and how it is created and the technologies that are required in its creation. After that, we will see a demonstration which will show the details of how this distributed chat application works and how a person or a user can chat on it with different users. In the end, we will conclude what we have made and see some references that can make all users understand how this application was made and the back research done on this. So, first, for understanding what a distributed chat application is, we have to understand that in modern days, there are n number of users which are communicating on a daily basis via text messaging. Chat application opens the door for text messaging on a large scale. And when we have to cater to a large population of people living across the globe, we need distributed chat applications to do so. A distributed chat application system presents a single system image to the users, and they do not have to worry about its distributive nature, but they see a single system, much more like a car in which there is an engine and there are different other parts, but the user only sees a car and how it has to be driven via using its tools. It allows multiple users to effectively communicate and send messages seamlessly across to each other on different chat rooms. Now, let's see what can be done. First, let's see the history of chat systems because chat systems have been around for a while. As you can see on the image on the right, chat systems have been around since the 1980s until now. They have just improved throughout. On a daily basis, users use applications like WhatsApp, Facebook Messenger, and much more. These applications allow us to communicate on a daily basis and improve our quality of life. Most chat messengers applications make use of centralized server or P2P network architecture. An increase in the number of users with internet connectivity warrants the need for a distributed alternative because without that, scalability will be an issue. Let's understand the features of our distributed chat application. Firstly, in this distributed chat application, a user can create an account and which allows the user to register himself. On registration, a user will be able to access a login page. It gives the user a capability of session. So each user that is using the application has his own session. This session allows his communication to happen in a flawless way in which it sends the message to server and receives the message in a client-server architecture. This single point connection for each user gives it the capability of consistency. Instant messaging provides multiple users the ability to communicate with one another. In this way, messages are received instantly with lightning fast speeds across the globe. Chat rooms allow all registered users to access the chat rooms and communicate with each other simultaneously. A message on the chat room is received by all users, and all users are able to see each other's messages and register and the timestamp of the message followed by who sent it on these chat rooms. Notification services. Notification services are for users to see when a user is actually entering and exiting a chat room and letting everybody know the presence of a person who would want to send a message or communicate with them. Let's understand the architecture of our distributed chat application in detail. When a user sends a message via the WebSocket to the chat service, it receives the message and in turn it also sends the user message not just in the group but send the user messages of other participants as well. The user, on joining the login, on joining a group, gets a notification that they have joined a group, and other users also get a notification that a new user has joined the chat room. The database reads and writes user login information to understand who is the new user and encrypt their data from end to end. This is how the architecture of the distributed chat application works. Let's go ahead and understand other parts. Now, to understand the implementation of this chat application, we have made a REST API. In this REST application, we are using Flask as the REST application backend. For database, we are using PostgreSQL database, and we are doing database replication over multiple servers so that we have a backup of data. And in case if one of the database server dies, another is always available via leader election. In this application, we are using Flask Socket IO to create session control. Session control allows a user to have his own session, and via this capability, we are able to send and receive messages flawlessly for every user. Data encryption is a very important part for a chat application, and we are using SHA-256 encryption algorithm to do data encryption from end to end. For our front end, we have used JavaScript and HTML. This gives us a capability to send data from client to server architecture. Now let's see a demonstration. As you can see on the image on the left, when we come and open the server for the first time and basically try to log into our chat app, if we are not a registered user, we are given a registration form, and we can register by putting in our name and password and creating that a user. Once we are registered, we are taken to a login page wherein it shows that we have successfully registered ourselves, and then we can put in our username and password again to log in. Now, as we can see, when we are logged in, we come to the default chat room, which is the launch room. This shows that we have joined a chat room, which is the launch room, and all users who log in come to this default chat room. There are multiple chat rooms in this application on which multiple users can communicate to each other instantaneously. Existing users notification of new user joining the chat room come to all the users. When we send a message in this chat room, it shows the username who sent the message body itself, and the timestamp of when this message was received. So that this message is consistent throughout the chat room, and everybody sees it in the order it was received. Now we can see over here a demonstration of what happens when two users are chatting with each other. Over here there are two users, Abhishek and user 77. As you can see, when a user 77 enters the launch room, his message comes to Abhishek itself, and the user 77 can also see Abhishek chatting in there. They can both talk to each other and see the timestamp of when their message was received and the message body itself. This is how the chat application works. Now let us conclude what we have seen till now. We created a real-world distributed chat application. It was capable of creating multiple users and provide end-to-end encryption. What could be a future work for this particular application? To see in detail, we can first develop a mobile application wherein the current application is a web application. We can have a mobile application wherein the user can have more features inside the application itself. We can include additional capabilities such as file sharing. Now, for file sharing, we can give documents like videos, we can give images, etc. After that, we can also provide typing status to online users, wherein if a user is typing, another user is notified that the current user is typing. We can also add auto completion feature so that a person who is typing doesn't have to take so much long to type. Here are some references of our work and research that we had to do to make this distributed chat application. Before I conclude this presentation, I would like to give a live demonstration of how our chat application works.
Let's see some of the code that we did to make our distributed chat application. In this application, we have used Flask to make a REST API. We are using Flask SQL Alchemy for handling databases, PassLib for implementing SHA-256, Flask Socket IO for implementing sessions, and we are using JavaScript and HTML for our front-end render. Let's understand this in detail. So, the Flask application has a basic secret key. This can be a more complicated key, but for making purposes, we have just taken a simple key. In this application, we are using two different PostgreSQL databases. One database is currently running on Heroku, and the second database is locally available in my system. These databases are working parallel to each other. As you can see, we are using Flask SQL Alchemy binds to run these databases, wherein we run both these databases together so that data can be saved on these databases simultaneously, and if one database stops working, the other takes its place. Now let's understand the application a little bit more detail. For the registration form, we are taking in the username, the password, and we are running the SHA-256 algorithm over the password to save it to the database. We are encrypting the password so that even if somebody has access to the database, they cannot get to the password of the registered user. As you can see, we are saving the data in both databases for the registered user. These databases can be seen in our model.py file. The models.py file shows clearly that in a database, the ID is the primary key and it auto increments. The username is a string which has to be unique and it cannot be left to null value. Password is also a string. It doesn't have to be unique, but it cannot be left as a null value. Over here, as you can see, bindskey.to redirects the database to the new database when we are trying to save our data to the second database. It has the same table structure. Let's see something in more detail. To run our application, one has to run the create.py file first. They can put their SQL Alchemy database URI over here, and using this URI they can then create their own PostgreSQL table which can run on their local system or on a Heroku or other server running the PostgreSQL database. To run the application, we run the application.py file. On running this application, it is currently hosted on my local host. Let's open it. Let's see in detail how the chat application works. Once you come to the chat application, you will be taken to this registration form. If you are a user, then you can directly go to the login page. But if you're not registered, then you have to register. Let's make a registration. Once you get registered, you get a registered successful message. Let's log in to the application. If you put in a wrong password and try to log in, you will get an error message saying that the username or password is incorrect. Let's put in the right password this time. Once you log in, you can see you come to the default launch room, which is a chat room. In this chat room, you get a notification that you have logged in, and this notification can be seen by everybody else who is currently available in this chat room in a session. Let's send a message. Once you send a message, you can see that your username, the message body, and the timestamp comes. And this way you can chat with other users. If another user comes in, they can chat with you in this chat room, and works exactly as shown in the demonstration in the presentation.